Today's video is going to reintroduce scientific notation because I know that we have all seen this before in previous math classes, and then we're going to expand on it a little bit. So first we're going to do some review. So scientific notation is a number in the form of C times 10 to the n, where C has to be between 1 and 10. So C is greater than 1 or equal to 1 and less than 10. And n is an integer. So again, it's going to be some number between 1 and 10. It could be equal to 1, but it has to be less than 10. It can't be equal to 10. 9.9999, not 10. And then it is raised, it's multiplied by, we have 10 is the base, and n is the exponent. So we are going to practice. We are going to rewrite some problems in decimal form. Decimal form is also known as standard form. There's scientific notation and then there's standard form. So, a couple examples. First one for you. I have 3.128 times 10 to the third. Because this exponent is positive, that makes the number bigger. So we're going to go to the right. So I'm going to take my decimal. I have a positive 3 up here as my exponent, so I'm going to move my decimal 3 to the right. 1, 2, 3. So my new number is 3,128. Same number, just written in scientific form and standard form. All right, so a couple more examples. I have negative 6.4 times 10 to the fourth. Again, I have a positive exponent, so my number is going to get bigger. I'm going to move it to the right. So I have negative 6.4. I'm going to move it to the right 4 spaces. 1, 2, 3, 4. I'm going to fill in my missing numbers with zeros. 1, 2, 3. My missing little swoops. So my number is negative 64,000. All right, so those both had positive exponents. Let's look at when we have a negative exponent. Let's say that I have 3.9 times 10 to the negative 1. So this negative exponent makes the number smaller. We're going to go left. Okay, so if I have 3.9, I'm going to go left 1 space because I have a negative means left and 1 space. So I'm going to go 1 space over my new decimal. I now have 39 hundredths. One more example. Again, this should all be a review because I know that we have seen this before. All right, so my number is 6.12, and I have a negative 5, so I'm going to go to the left 5 spaces. 1, 2, 3, 4, 5. I have to fill in my divots with 0, so my number is 0.00000612. All right, so that's how you rewrite in decimal form. So we're going from scientific notation to standard or decimal form. So now we're going to go the other way. We are going to rewrite, that's an E, in scientific notation. So first example. I have 5 to 52,314. So first thing I have to do is I have to make this a number between 1 and 10. So to do that, I have to put my decimal right here in between the 5 and the 2. So now my number is 5.2314 times 10. And the way that I'm going to figure out what exponent I'm supposed to have, I'm going to see how many spaces are to my right. 1, 2, 3, 4. So that should be an exponent of 4. So my number as a scientific notation, 5.2314 times 10 to the 4th. Again, you can go and check yourself. When you move it 4 to the right, do you get the same number? Yes, you do. So you're good. All right, next one. 3.2. Well, 3.2 is already in the right form. So we can actually rewrite this in standard form. 3.2, you don't need to change it. It's between 1 and 10, and this is times 10 to the 0. And that makes sense, right? We know that 10 to the 0 is 1, so 3.12 times 1 gives us 3.12. All right, a couple more. I have negative 0.0471, okay? We are going to write that in scientific notation. So first thing I got to do, I have to make this number between 1 and 10. So I'm going to put my decimal right here. So I'm going to have 4.71. But we do have to consider the negative. That negative needs to be there. All right, well now I'm just going to count how many numbers are between my decimals. Zeros count. So 1, 2. So this would be times 10 to the negative 2. When we do these examples, numbers less than 1 will have negative exponents. All right, one more example, and then we're going to get into some new stuff. So last one, I have 0.00000428. All right, first I'm going to make my number between 1 and 10. I'm going to do that by putting the decimal there. So I have 4.28 times 10. And let me see how many numbers between decimals. 1, 2, 3, 4, 5. So it's a negative 5. Remember, because numbers less than 1 will have negative exponents. All right, so that should have been a review up to this point. So now we're going to look at computing with scientific notation. So we're going to do a few extra things. And I'm just going to abbreviate scientific notation. Okay, so first thing. When we have numbers in scientific notation and we are multiplying them, so first you're going to multiply the first values, then combine the powers. And what I mean by that is first you're going to take the 2.5 and the 5.8 and you're going to multiply them. 2.5 times 5.8. And what do you get? We get 14.5. The next thing you're going to do is you're going to multiply your powers. Well, your powers. So I have 10 to the 4th times 10 squared. And we all know that when we're multiplying exponents with the same base, we add the exponent. So this is 10 to the 6th. So then we're going to go and put these together in scientific notation. So I have 14.5 times 10 to the 6th. And I'm done. But am I? I am not done. The reason why is because this 14.5 is not in the right form. That number is not less than 10. So we got to redo it. We got one more step. I'm going to change this to 1.45 times 10. And since I changed it, I have to move this to a 7 instead of a 6. Okay? Look at another example. All right, so now we're going to divide. All right, so we have 1.82 times 10 to the negative 1, and 1, sorry, that should be a decimal there, 1.4 times 10 to the negative 3. We're going to do something very similar. We're first going to divide our numbers, 1.82 divided by 1.4, and then we have 10 to the negative 1 divided by 10 to the negative 3. Okay, so when you divide this, 1.82 divided by 1.4 is 1.3 times 10. Now, when we subtract this, you can look at this two different ways. You can say negative 1 minus a negative 3, right? Minus a negative becomes plus. So negative 1 plus 3 is 2. So this would have an exponent of 2. Remember, because when we have quotients, we subtract the exponent. Or you could make these, since these are both unhappy, you can make them happy. 10 to the negative 1 would go down to the bottom and become 10 to the first power. And 10 cubed would go to the top as 10 cubed. And now when I subtract them, I get 10 to the second. Okay? Same answer, but just two different ways of getting it. All right, just two more examples. Example 3, we are going to raise this to a power. All right, so we're going to, like we did before, we're going to kind of distribute this to both. So this is going to be 1.5 cubed times 10 to the negative 4th cubed. All right, 1.5 cubed gives us a value of 3.375 times, and we know how to do a power to a power. We're going to multiply 10 to the negative 12th. All right, again. All right, that's it. Yeah, 3.375 times 10 to the negative 12. Good. All right, last one here. Okay, so again, we've done a problem like this. So we know we have to break it off the parts and we're going to divide. So I have 1.1 divided by 5.5, and I'm multiplying this by 10 to the negative 1 divided by 10 to the negative 5. So 1.1 divided by 5.5 gives me 0.2 times 10. I can do two things again. Negative 1 minus a negative 5. This becomes plus and equals 4. So that would be a power of 4, or I can make them happy. 10 to the 5th goes on top. 10 to the 1st on the bottom. We know when you have a quotient with exponents, you subtract 5 minus 1 is equal to 4. Either way, you get 4. Again, like before, we notice that this is not in the right form. We have to move the decimal to the right. When we move the decimal to the right, we subtract 1 from this number. So 2.0 times 10 to the 3rd. Before, we moved the decimal to the left. We went from 14.5 to 1.45, and we added 1. Here we subtracted 1. Okay, so you have to know the difference, and you can always change the form to check yourself. All right, we'll do a lot more of this when I see you in class.